All right, let's do one more thing that's matrix related. Welcome, welcome. Let's do one more thing that's matrix related. Let's solve a system. This particular system is x plus 3y plus 5z is 45, and 6x minus 3y plus 2z is negative 10, and negative 2x plus 3y, oh, that's a mess, plus 8z is 72. Sorry, folks at home. Or wherever you're watching this. Wherever you're watching this is fine. We could turn this into an augmented matrix, put that augmented matrix into reduced row echelon form, and see x, y, and z pop right out. Let us think of this slightly differently. We recognize that the left side has these coefficients. And the coefficients are really where the meaning is. But it is also true that the left-hand side is the product of two matrices. Really, I mean, if you were to put the brackets around here like this, that matrix, that 3-row, 1-column matrix, would be the result of this. 1 times x plus 3 times y plus 5 times z, and so on for the other rows. Which means that the matrix on the right is also a 3 by 1. Those matrices are the same. So why would we write the equation this way? Why would we turn the system into a matrix equation? What's the advantage? Well, we can get this, we can isolate this matrix if we can get rid of that one. Wouldn't it be nice if we could divide? But we can't. So what do we do instead? We multiply by the inverse of this 3 by 3. And if we multiply by the inverse of this 3 by 3, then those result in the identity, and that basically goes away. So now, this inverse matrix also has to appear on the right side, but matrix multiplication is not commutative. So if we left multiply on the left side, we have to left multiply on the right side. Now, previous lessons have taught us how to find this inverse. We could append an identity matrix, convert to reduced row echelon form, come up with the inverse that way. I'm going to do it in a slightly faster way. I'm going to ask the calculator to do the work for me. Let's go to the calculator. Let's make a 3 by 3 matrix. And that 3 by 3 matrix is 1, 3, 5. 6, negative 3, 2, negative 2, 3, 8. We want to find the inverse of that matrix, and we want to multiply it by a 3 by 1, and that's 45, negative 10, and 72. And the calculator does all the work for us! Negative 2, 4, 7. The calculator does all the work for us. X, Y, Z is negative 2, 4, 7. So let's take a look at the deep structure. What is really happening here? This equation is of the form sum matrix A times some matrix of variables is some other matrix B. So the matrix of variables is the inverse of A times B. If we can convert a system of equations into a matrix equation, we can solve that matrix equation. Normally we would say B divided by A, but with matrices we can't divide. So instead we multiply the inverse of A times B. It is time for you to practice. Based on what you've read and what you've seen, you want to solve A plus 4B plus 6C is 23. A plus 2B plus C is 2. Negative A plus 6B plus 2C is 14. Take some time, turn it into a matrix equation, solve that matrix equation. Do you have work that looks roughly like this, where we've taken the 9 coefficients on the left side, turned them into a matrix, A, B, and C come in this order, and then we've got the constant matrix on the right side. So to get A, B, C by itself, we want to undo what this did. And we undo what this did by multiplying by its inverse. A 3 by 3 times a 3 by 1 is a 3 by 1, and we can find that. So let's go back to the place where we do that. We're going to create a matrix. It's a 3 by 3. And that's 1, 4, 6, 1, 2, 1, negative 1, 6, 2. We want the inverse of that times, we make another matrix, and that matrix is a 3 by 1, and it's 23 to 14. And we get that A is negative 3, B is 1/2, and C is 4. So once we get that matrix, negative 3, 1/2, 4, we now know that A, B, C is negative 3, 1/2, and 4. That's the solution to the system. And it does not matter. This idea holds whether it's a 2 by 2 or a 3 by 3 or a 4 by 4. The size of the system now doesn't matter. We have a mechanism by which we can solve the system that works regardless of the size of the system. The process is just as easy to solve a 5 by 5 as it is to solve a 2 by 2. So all that work we did early on where you were like, why am I doing this in a 2 by 2? This is so much easier to do the way we did in 9th grade, because this method scales up. And I hope that you can see that solving a 4 by 4 or a 5 by 5 would be exactly the same. All right, we'll see you when we gather at the start of week 3.